Howdy students. In this video we're going to go over some examples of algebra and how to work out these problems. Now, most of you probably already know how to do this. This is literally 10th grade math. That said, I realize some of you haven't seen this since 10th grade and may be out of practice, and other people may never have learned this. In any event, consider this a good opportunity to bone up on your math. Simply saying, I'm not good at math, or I didn't realize there'd be math, is not a good way to live your life. There is math everywhere. If you go in to buy a house, there's math involved in the mortgage calculations. You have to be able to do this in order to be a really well-informed, good citizen. All right, so let's start off with this problem. Now, what we're trying to do is calculate the solar constant given values of surface temperature, number of layers, and albedo. Now, when you see a problem like this, you can always draw a diagram and try to work out all of the fluxes from the top of the atmosphere on down to the surface. That will work. You can solve the problem that way. But you should also ask if you can just use our favorite equation, equation 4-5, to do the calculation. So let's write down equation 4-5. Temperature equals the fourth root of n plus 1 times s times 1 minus alpha over 4 sigma. Okay, so this is our favorite equation, and you can see that there are 4 unknowns in this equation: temperature, n, s, and alpha. If I give you 3 of those unknowns, you can solve for the last one. So in this case, I've given you temperature, n, and alpha, and you need to solve for s. So let's go over how we would actually do this calculation. Oh, and I should mention, as always, this is a sigma. Sigma is a constant, 5.67 times 10 to the minus 8. So let's start solving the problem. The first thing to do, let's substitute in the values we were given. And I'm just going to leave, make sure that covers both those, and I'm just going to leave sigma. I'm not going to write that out. I'm just going to leave that as a constant, but just remember that's 5.67 times 10 to the minus 8. All right, so how do we solve for s? Because that's essentially the problem here. So what we need to do in order to solve for s is we need to move everything else to this side of the equation. So that's always what you try to do in algebra. You always want to move everything other than the variable you're trying to solve for to the other side of the equation. So let's do that. So the first thing we have to do is we've got to get rid of this ugly fourth root. So the way you do that is you raise both sides of the equation to the fourth power. So we're going to do 251 to the fourth equals fourth root of 3 times s times 0.3 over 4 sigma to the fourth. So you see what I did is I've taken both sides of the equation and I've raised them to the fourth power. Now, the fourth power of the fourth root, they cancel each other. So you end up with 251 to the fourth equals 3 times s times 0.3 over 4 sigma. See that? So I've gotten rid of the root by raising both sides to the fourth power. I have 251 to the fourth here, and now I have just a ratio here. The radical is gone. Okay, so where do I go next? I'm going to erase this up here. I'm going to start writing. All right, so once you get it in this form, you want to move everything other than the s to this side. So let me write this. 251 to the fourth equals 3 times s times 0.3 over 4 sigma. So let's get rid of this 3. Let's move this 3 over to the side. The way you do that is you multiply both sides by 1/3. So I divide by 3 or multiply by 1/3 here. I divide by 3 or multiply by 1/3 here. Now this 1/3 cancels that. So I've effectively moved the 3 over to this side. Now let's move this point 0.3. I do exactly the same thing. I divide by 0.3 here, and I divide by 0.3 here. So this 0.3 cancels that 0.3. So now I've moved that here. And so you can kind of guess, how do I move this 4 sigma from this side? Well, I multiply both sides by 4 sigma. And I cancel that. So I just imagine me multiplying by 4 sigma. I don't really have room. Imagine, but effectively that's what I'm doing. I'm multiplying both sides by 4 sigma. So the 4 sigma appears here and it disappears there. So now I can say that 251 to the 4th times 4 sigma over 3 times 0.3 equals S. Okay? So that's essentially the algebra. Now I'm not going to work out how you actually do this calculation. I did another video that goes over using your calculator and common mistakes you make. I assume that if I give you something like this, you can plug in the numbers and get the right answer. So make sure you know the answer. In case you're wondering, the answer is 1,000 watts per meter squared. So if you plug all the numbers in there, you should get 1,000. If you don't get 1,000, then you need to really make sure you understand how to use your calculator, because it's then a calculator problem. Okay, so let's do one more. We'll do one more problem. So here's the problem, and we're trying to solve for temperature. In other words, we're asking what temperature gives you 238 watts per square meter of power being emitted from a black body. Now we know the equation that we're going to use. It's Stefan-Boltzmann. Anytime I ask you a question about power and temperature, think Stefan-Boltzmann. So Stefan-Boltzmann says power over area equals sigma T to the 4th. Now I told you what the power over area is because I gave it to you in units of watts per square meter. That's power per area. And so that's 238 equals sigma T to the 4th. So now you've got to solve for T. So how do you do that? Okay, again, remember, sigma is a constant. Okay, 5.67 times 10 to the minus 8 watts per square meter per Kelvin to the 4th. So this is just a number. And I'm not going to write it out because it's painful to write out. It's much easier just to write sigma. So the first thing to do, as I said before, when you're doing algebra problems, is move everything to the other side. Isolate the variable you're trying to solve for. That should be all by itself on one side of the equal sign. So this means we got to move the sigma over here. And the way we do that is we divide both sides by sigma. You can always multiply or divide both sides of an equation by the same number. So if I divide both sides by sigma, those cancel. I get rid of the sigma, and the sigma appears over here. So in other words, 238 over sigma equals T to the 4th. So I've done the first step. I've isolated my variable I'm trying to solve on one side of the equation. But now I've got this 4th root. I have a 4th power on this side, and I've got to get rid of that. So what do? Well, the way you get rid of this is you take the 4th root of both sides of the equation. So and the 4th root of T to the 4th is just equal to T. The 4th root and the 4th power cancel each other. So the answer to this problem is 238 divided by sigma, and you take the 4th root of that, and that gives you the temperature. Now, how do you actually take the 4th root? Okay, there are 2 different ways to do this. Let me erase this up here, and I'll erase this also. So there are 2 ways to do that. So one of the ways is your calculator has a y to the x button on it. It almost certainly does. And what this says is it allows you to give it a value y, and it allows you to give you value x, and it does y to the x. For the 4th root, x is 0.25. Okay, so it's 1 over 4. That is the 4th root. And so you can use a calculator. You can use your calculator's y to the x button to do the calculation. Just calculate 238 divided by sigma, and then use the y to the x button with x equals 0.25. The other way to do it, in fact the way I do it, which is quite a bit faster, is that the 4th root of x is equal to the square root of the square root of x. So you just take 238 over sigma, you hit the square root button, and then you hit the square root button again, and that will give you the right answer. So either of those things work, but make sure you know how to do that. Now, Now you should actually probably already know what the answer is. If something is emitting 238 watts per square meter, the temperature is 255 Kelvin, because 238 is the energy in for the Earth, something you should remember. And if the Earth had no atmosphere, then the surface temperature would also be emitting 238. And we calculated in previous videos that this gives you a temperature of 255 Kelvin. So you should be able to solve this, and you should be able to get 255 Kelvin out of this. Make sure you can plug these numbers in and get this. If you can't do that, then that's a calculator problem. Watch the other video I did about using your calculator to hopefully head off potential problems you have with that. So that's it for this video. I hope these example problems helped you. For additional help, do the practice homeworks. Make sure you can do those. If you're still having problems, go to office hours. And now, you know what time it is.
Are you awake, Paul? Are you awake? Do we need to go out and back?